what our inquiry lab question is for us. Damien.
The number of students who bring their lunch. Wait, no. Is that the right one? Okay. The number of students who bring their lunch to Phoenix Middle School has been decreasing at the rate of 4 students each month. What indicator represents the total change in the number of students bringing their lunch after students?
Okay. First of all, I want you to go through and underline, what do you know? Underline, what do you know? So what information are you given? Addie, get your head up off the desk, please. Sit up. There we go. Underline what you are given. Yep. Then write it down. So Trey, write it down. What you are given. Then underline what are you trying to find? And write it down in words. All right, Miss Addie Swanson, what's one thing that we know? Okay, so it's decreasing at a rate of 4 students each month, yes? Decreasing at a rate of 4 students. Did anybody write anything else about what we know? We're going to look at 3 months. Okay, so after 3 months, what are we trying to find? Jada? Okay, so the total change. What else did you put for what you know? That's true, yep. Okay. Jacob, did you have that written down? Write it down. Okay, before we go on to the solving the activity, I want to quickly remind you about multiplying, okay? So if we have something like 2 times 4, when you first learned multiplication and you didn't have your facts memorized, you were taught that you have 2 groups of 4, right? So I could draw 2 groups, and each of them would have 4 in it, correct? So then I would count, 2 times 4 is 8, because there's 8 total there, right? So then if I have 5 times 3, you're just listening. You have 5 groups of 3. So how many groups do I draw? 5. And then how many do I put in each of them? 3. So then what do I get for an answer? If I counted up all the little dots, I would have a total of 15. Everybody remembers that, right?
Yeah, I'm learning in like
Okay.
4th grade with it first.
Yeah, you learned that a while ago. So then we're going to apply that to what we do today. But what is the commutative rule? Or the commutative property? Raise your hand. Commutative. Caden? So I can change the order of the numbers, but my answer doesn't change, right? So 2 times 4 is the same as 4 times 2, correct? I could have 4 groups of 2 and I would still get 8. And I could have 3 times 5 and still get 15, right? Okay, so keep those things in mind as we go into our lesson today. So going back to our problem, it says the hands-on activity, we need to write an integer that represents a decrease of 4. What's an integer that represents a decrease of 4? Negative 4. So let's write negative 4 right there. So negative 4 represents the decrease each month. Each means what? Add, subtract, multiply, divide. Each. Okay, if you're not going to shout productive things, don't shout at all. Think about it, each. If you're going to do something each time, are you going to add, subtract, multiply, divide? Jada? No? Nope. Damien? Multiply, okay? So like if each day you run 5 miles, day 1 I ran 5, day 2 I ran 10 total, right, for the whole week. Day 3 I would run a total of 15 because I ran 5 miles each day, right? So the same thing goes here. If we have 3 months and it's decreasing each month 3 times negative 4 because that's the number that is decreasing by. Everybody good at that? Okay, so then I apply what I just reminded you guys of. I have 3 groups, 1, 2, 3, of negative 4. So I have 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4. So how many do you have total? 12. And are they positive or negative? So there are 12 negative counters. So 3 times negative 4 is negative 12. So after 3 months, the total change in the number of students bringing their lunch will be negative 12. You're decreasing by 12 students each month, so yes. Because I'm reducing the number of students who bring their lunch, or eat school lunch, whichever it is. Okay? Questions so far? Okay, go to the next page. On this page, I'm going to show you 2 different ways for this example. The first way I'm going to show you is going to be using the commutative property. So Trey, how could I rewrite negative 2 times 3? No, you can't change the value of numbers. How could I rewrite it so that it's in a different order? 3 times negative 2. Okay, so this is not in your book, so I would write it in your book. So 3 times negative 2 is the same thing as negative 2 times 3, right? Okay, so this tells me I have how many groups? 3. 3 groups, so let's draw 3 groups. How many are in each group? 2. And are they positive or negative? Negative. So I have 2 negatives in each group.
So you pretty much just times them.
Well, let's not blurt things out. Addie D, what would our answer be? Positives or negatives? What? Are you following along with me? I don't have any positives right there. Gracie, what do we have? Positives or negatives? Negatives. Because I have 3 groups of negative 2. Therefore, there's 1, 2, 3, 4, 5, 6 negatives. And your answer would be negative 6. That's one way of solving that problem. Now, the book does it a different way. The book, if I take the original problem and kept it this way, this sentence would say, remove 2 sets of 3 positives. So I'm going to take away 2 groups of 3 positives. Do I have anything to take away right now? No. No. So what do you think I'm going to do so that I have things to take away? Make a picture. 0 pair. 0 pair. Okay. So how many 0 pairs do you want to add to the mat? Okay, if I add So this is my new mat. If I add 2 0 pairs, can I take away 2 groups of 3? No, so how many more do you want to add? Okay, if I add 1 more, can I take away 2 groups of 3? I only have 1 group of 3.
Oh, no.
So how many more do I need to add?
3 more.
3 more. So I actually have a total of how many 0 pairs? 6. Okay. Now, do I have 2 groups of 3 to take away? Yes. So if I take away, here's 1 group of 3. Here's 2 groups of 3. What are you left with? 6 negatives. Isn't that what we got when we did it the other way?
Yes. Otherwise,
Yes.
The other way better.
And you can do the other way better. However, my next example, you have to do 0 pairs. Okay. Questions about this method so far? Okay. So let's go on to the next example. This time you guys have to draw it out with me.
what did we write in step 2?
Just move on to the next example. It's okay if it's blank. Okay. So in activity 3, we have to use -2 times -4. So both factors are negative, and I need to remove 2 sets of 4 negative counters from the mat. That's what -2 times -4 says. I need to take away 2 groups of -4. Do I have anything to take away?
No.
No. So I'm going to have to add some
The negative is 0 pairs.
0 pairs. How many do you want to add?
8.
Let's add 8. So if I add 8 positives, I have to add 8 negatives, correct? 6, 7, 8. So everybody should be drawing this with me.
Unless you don't know which one to take.
I hope that.
I mean, I know.
Everybody good so far?
I'm still.
Drawing? Good. Okay, so this says I need to take away 2 groups of -4. So this time I'm going to remove the negative one. So if I take away 1 group of -4 and then 2 groups of -4, what are you left with?
8. I mean, 8 positives.
8 positives. So there are 8 positive counters remaining. So -2 times -4 is 8.
Wait, so you just.
Nope. Nope. Do you have a question about this or a question about rules? Okay, I'm going to do one more of this type with you, and then you have to do the others on your own, okay? So go to the next page and look at number 6. Number 6. It says to take away 2 groups of -4. Isn't what we just did?
Yeah.
Okay, let's skip that one. Let's go to number 7. We'll do number 7. So you shouldn't get that one wrong because it's the one that we just did. So number 7, we need to take away 3 groups of -1. Do I have anything to take away?
No.
Okay, so I'm going to add some what?
0 pairs.
0 pairs. How many do you want to add?
6. 3.
Let's add 3. Let's start with that. If we need more, we can always add more. So if I add 3 positives, I have to add 3 negatives. Now it says take away 3 groups of -1. So if I take away, here's 1 group of -1, 2 groups of -1, 3 groups of -1. What are you left with?
I don't get how they're both negative and it ends up.
Because you're removing negative counters, therefore you're only left with positives. Kind of like when we take away negative counters, you're only left with positives.
Why do we have to do this?
Because you get a fundamental the reasoning behind the rules. If I tell you rules, it has no reasoning behind it. It's not understanding, though. It's just memorizing. Memorizing is not going to get you very